Alrighty, boys and girls, and welcome to today's lesson on constant of proportionality. Your essential question is going to be understanding the relationship between y equals kx and k equals y divided by x. Write that down. Have out your Cornell notes and get ready to go. So here are some examples, and this is why rate or unit rate is so important. This is going to help you to compare some of your different amounts. As you notice, when they do the dividing on the 19/2, it becomes the 950. Each one of these is going to have the same unit rate, and you can tell that that's what's going to be making them proportional. Now, I'm going to go ahead and work through the example in your trainer, but know that this is the type of relationships we are looking at. We're finding out whether or not what you are setting up is proportional, deciding does it continue to increase by the same amount and does it have the same unit rate. These are the type of problems that we're going to be working through and solving. So here we go. The very first question we're going to look at is, based on the information in the table, is the relationship between the time and the number of words proportional? So let's see here. This one is 1 out of 35. That simplifies to 1 out of 35. Another 35 would be 100. Yeah, 135. Yeah, this is 1 out of 35 every time. So yes, this is a proportional relationship. Now, the number of words divided by each minute is going to be, let's see if I can type that, 35 out of 1. Now, here's what you may have noticed. When you have your x is always going to be the bottom number. Oh, it's not writing. Okay, I got it to write. X is always the bottom number, and y is going to be on top. Remembering that this x is stuff like time. Time is dependent, and your y is your independent. Pretend I could write all that. Oh, I'm not going to be able to. Let's zoom back out. Push the fancy button here. Drag and zoom. Alright, got that fixed. Wouldn't be a Miss Fraser video if we didn't have some mistakes. Here we go. Let's check that answer. Well done. Next problem. Alright, again, we're going to make sure that we are setting this up where you're always putting y on top over x, because you want to have that dependent variable on the bottom. You want to have that dependent on the bottom, just like you would your donkey. So I can tell right off the top of my brain here that this is going to be 4 over 1 as the unit rate. So let's see if that's consistent. Times 4, yes. Times 4, yes. Times 6, yes. Times 6, yes. Times 8, yes. Times 8, excellent. This is the right proportion, so let's go ahead and fill this out as the constant rate. The constant rate of proportionality in this example would be equal to, we said, oh, you know what, now that I'm looking at it, I said 4 over 1 because that's how it's set up, but if you look at the chart here, 4 is x, this is y. I need to flip that. I need the reciprocal. The reciprocal is going to give me the y on top, which you must have. You have to have the y on top, the x on the bottom, so you really have 1/4 here. So let me try to type that in instead. Get rid of the marker. So I'm going to type in my fraction of 1. Nope, not like that. 4th. Let's see if I can go to the next one, which means my equation is going to be 1/4 x. So we've got 1/4. Let me go back to my letters. 1/4 x. Because of the other formula that we use that said, oh, what I push, that says y equals kx. So as you can see here, we said k was 1/4, which means y equals 1/4 x. Awesome. Next question. Let's continue going through here. How can you represent the proportional relationship using an equation? Find the constant. Constant seems like it could start with a K, so constant goes with K if I can pick it. There it is. An equation for proportional relationship is y equals kx. So let me make sure I'm doing this correctly, because your two choices are y equals kx. But if I wanted k to be alone, k would equal, let's see here, divided by, oops, that should be divided by y, divided by y. Oh, wait, I did it backwards. Divided by x, divided by x, because that eliminates this, leaving k alone. So it will be y over x equals k. So then let's see which one we're supposed to pick. K does not equal x times y. So let me get rid of my ink. There we go. Excellent. Alrighty, so let's continue. Each equation that gives the cost of the rent for x in days. So we've got to figure out what y equals. Remembering again that y equals kx. So let's solve for that. What is kx? Let's see. Cost. Money is always going to depend. Time is independent. Time is x. Cost is y. Why do they always flip that on us? It's always upside down, it seems like. So let's take, since if we're going to find what k equals y over x. So y needs to be on top. So y is 55.50 and x is 3. So Norman into the house, 55.50. 3 outside, 1 time. Subtract that. 2 left over. I'm about to have a serious issue here. 3 into 25. 7 times is 21. Wait. 8 times is 24. 24. I'm wondering if I can erase without erasing everything. Let's try this. We're going to make this work. Okay, then let's go back. Alright, so that would be 1, bring down the 5, 15, 3 into 15, 5 times. Don't forget we're sad. When you are sad, when you subtract, add, and divide, you line up your decimals. Pretend that says decimals. So 3 into 15, 5 times. Then bring down the 0. Oh, look, 3 goes into 0, 0 times. So then y should equal 18.5. Because that's kx. Let's see how we... Oh, I got to get rid of the ink. Oh, down here. Y equals... Oh, I already forgot. It was, I think, 18.5. Let's try it. 8. No, not on there. Text box. Text box, text box, text box. Clicking text box. Alrighty, here we go. 18.5. See how we did. Try again. You have to enter the correct value for the constant proportionality. Remember, y equals kx. So go back to our formula here. See, y equals kx. We solved for k. We said k was... Oh, you know what? I forgot the x. That's what I forgot. Ah ha ha! So simple. Got it.